Hello there everybody. My name is David Evans. I'm the Director of Research and Development at CADlink Technology. And I'm going to be going through printing white ink in digital printers such as inkjets and a new methodology to simplify the workflow. The main areas for white ink usage at the moment is UV and DTG printing. There are well over 10,000 DTG printers now in the market. The DTG is a well-established and mature market now. Sales of UV printers with white and clear are well into their thousands, and we're seeing really large growth in desktop printers for printing things like phone covers and specialist areas such as cylindrical printing, bottles, textured and ADA. I think in particular the UV market is a market that we've seen as a company huge growth in the desktop area, and we're expecting to see over the next 5 years a fairly large increase in the sales of these machines as the machine prices come down, and pretty much my experience is that over 90% of these machines, 95% of these, are being sold with white ink and clear. These new printing technologies have new challenges, and one of the problems with printing with white and clear is the complex file preparation required. Different substrates handle different amounts of white and clear, so you have to be able to control this. But there's also the issues of just generating where you want to print the white and where you want to print the clear ink. Because you have to do file preparation beforehand, that's going to increase your costs and also increases your graphics design skills and puts your graphic design skills in places where you may not want them, such as the print production room. Let's look at a case of just printing white. On the left hand side here I have an image of a pub logo that I want to print. In order to print this with white ink on, say, a black substrate, you have your colour pass you need to do, and then you have your white underbase, which is shown on the right hand side here. So we might have this as original PDF or an EPS file, and somehow you've got to generate the white underbase for that, where it's not just a matter of putting white down where you want colour, because you might have white letters and you need to put the white ink under the white letters as well as the colour. So it's knowing where you want to put the white and where you don't want to put the white that's the trick. The current methods of printing with white ink, there are sort of three main methods of doing it. One is called valid pixel. These are the three main markets in the market today. With valid pixel, what you're basically going to do is you're going to put the white ink down wherever you see some colour. So this means that in order to print white ink where you have white text, you would actually have to alter the white text to be a very slight off colour. It's typically done by making it sort of a very, very, very light tint of yellow, like a 1% or less, because visibly you won't see a 1% yellow, and that way you can generate the white ink down there. The downside of this method is that it involves editing the original graphics, and you're also limited to hard edges. There's no methodology in that process for doing, say, a gradient or something where you want to blend from the white to the background colour. Second method, which is predominantly the biggest method used in the DTG industry, is to use transparency. So in this example we have a transparent bitmap. We've converted the PDF to a bitmap, and where there's full transparency you don't put any ink down. Where things are completely opaque you put solid white behind it. If there was a 50% transparency you could generate a 50% white. This is really how black shirts and coloured shirts are done in the DTG industry now. and it works very successfully. The downsides for the UV market is that you have to convert things to a bitmap, so you're typically then printing at a resolution of say 300 or even 600 dpi. If you're printing UV, particularly if you're doing things like phone cases, you want to be printing at the highest resolution possible because you're printing small areas, often with small text, so you want to be printing at the resolution of the printer, which might be 1440 dpi. So if you're converting everything to a bitmap first, you're going to be losing in terms of the absolute quality you can print. The other side of it is that if you had any spot colour matching systems, be it Pantone or any other kind of name colour system, that's not going to work because there is no name colour system structure in a bitmap. The last and final method which is the actual traditional pre-press and the traditional sort of screen printing process, is to what we call working with spot colours and overprints. And in this case, what you would do is you'd create an object, which is the object you want to print. You would name it a spot colour, in this case white, and you would make it an overprint. This has no real disadvantages. You can create a PDF file from it or an EPS file. You can do gradients. The only real disadvantage is a huge amount of preparation work to the artwork. The more complex the graphics is, the more difficult it is to create the original graphic that you want to print. And the final one, the overprint white, is typically how most UV companies work today. So we work quite a lot with UV companies, and we're very aware of the issues in the print room, where you have increases in your production cost, because the customer doesn't deliver you artwork with the overprints and the whites all set up. You're going to have to do that work yourself. There's a specialist knowledge in doing that. Many people will say they're a graphics designer and be very good in Illustrator, but when you ask them to design with a spot colour and use white as an overprint, they have no idea what you're talking about because nobody told them about white overprints. The other thing is if you've got to edit your artwork for a specific output device, you're more likely to have a mistake. If you've got your original design from a customer and then you make changes to it and something goes wrong at that point, you're responsible for the changes, not the customer. And any reprints or anything like that are going to come from your costs. So we wanted to make the whole thing as easy as possible. We wanted to make it as easy as printing CMYK. Sorry, I missed one of the slides there. So, and we've done that. Basically what you do is you take your PDF or EPS file, or it can be a bitmap as well, and you just add it to a queue. The queues are set up, they're presets. So they could be for printing CMYK only, but they could be white on CMYK, or CMYK on white, or clear on CMYK, or even the case where you print white, CMYK, and then clear at the end. You just literally drop the file in, you don't have to alter the graphics. It's as easy as it can be. And this is available now. So how does it work? It works by using the opacity of the graphics. What I've done here is I've taken a screen capture of the original graphics in Illustrator. And on the left hand side I've drawn a blue box at the background. That is just to illustrate the opacity of the objects. Because what we're actually going to do is we're not going to care whether it's white or green or blue. In the same way as working with that transparent bitmap, we're going to look at the opacity of the graphics. So where an object is opaque, we will put 100% white down. Where it's clear, we won't put any white down. It means that if you have things that are 50% transparent, you'll get 50% white. So this allows you to take any EPS, any PDF file, the same file that you would print in your CMYK workflow, you can now print, and you can automatically generate the white or the clear on the fly. There's no editing required whatsoever. In this example, I've just done the one screen capture, which is an iPod logo. probably not allowed to use it, but what the hell. But you can see it's got a soft shadow. The soft shadow on the right hand side, it shows you the opacity information, and that's exactly how the white would be printed. So what you've got now is you've got the main opaque objects printing with a solid white, and the soft shadow will now reproduce as a soft shadow onto any substrate you printed to. So you could take this logo, suitably done for an iPod, and you could print it onto a green iPod, a yellow iPod, a red iPod, or a black iPod, and it's going to give you the colours and the soft shadow onto that object without any special alterations whatsoever. And bear in mind, this is the original graphics. This is the original PDF file that comes out of Apple, and it has had no alterations done whatsoever. Any named colours, any Pantones or anything like that, all that colour matching is going to be carried through. The other good thing about this is the designers don't have to learn anything. The designers do what they're used to doing. They're used to creating shadows and everything. So you don't have to teach a designer to do anything other than what you would normally do for CMYK output. Within our software, within the queues, how they're set up, each queue has a layer feature. A layer is a pass on the printer. This is the way we can set up for doing different layers, where we want to print white colour or colour white or whatever. So you can have as many layers as you like, and each layer then has attributes set to it. In this case, we've got an attribute where we're generating an underbase. So in the left hand side you can see we have two layers, underbase and colour, and on the underbase layer, which is currently selected, we're going to generate the underbase. On the left hand side you can also see all the channels we're printing. So we're only printing the white channel in the first pass. If we would look at the colour tab, you would see there would be no underbase generated, the white would be disabled and the CMYK would be enabled. So by configuring layers you can basically configure any number of combinations you want to output. So similarly we could create a third layer where we would have clear, no CMYK, and just generate the clear instead. Alignment can always be difficult. If you're printing on an inkjet, no matter how good you think your registration is, my experience is that it's never perfect. So we have things like an automatic choke facility, which will choke in the white. The maximum white can be changed. Depending on the substrate you're printing on, and whether it's DTG or UV, you may want to adjust the amount of white you're putting down. If you're printing onto a very light yellow substrate, you may not need to put as much white down as when you're printing onto a black substrate. And the white inks tend to be more expensive, so you want to do cost savings. By using queue configurations, you can set up presets of queues for as many configurations as you need. And once they're set up, you don't have to adjust this on a job-by-job basis. Similarly, as we choke the white, we can spread the clear. So the benefits of this is working with transparency is naturally an intuitive part of designing. Most graphics, most existing PDF and EPS files out there will work without any changes. You can just take them in, drop them on the queue and start printing them. There's no requirement for print production to understand graphics editing. There's no in-house requirement for experts to alter graphics. You're going to get the highest quality because you're working from the PDF. You're going to get text rendered to the resolution of the output, as are vectors. Spot color matching works. There's no flattening of transparency areas. There's no pre-flight required. In fact, we don't want you to do pre-flight. Pre-flight's what you do for offset, for flattening transparencies. We don't want you to do that. So we're taking out these steps. And there's no color shifts. If you've got a PDF file that's a mixture of RGB, has an RGB bitmap and some CMYK vectors, they're going to get rendered to the output from RGB and CMYK. They're not all being rendered to a common color space. Well, that's really it. If you'd like to have more information or a product demonstration, please come to our stand at F31A in Hall 8. And if you have any questions, you can take the headphones off and talk normally like human beings.